Hello guys, welcome to Pepcoding, and now I'm going to discuss the next question, that is map some pair. Okay, so let's see what we have to do in this question. So we have to perform these two operations. Okay, so the first operation is insert, in which we are receiving the two things. That is, the first thing is the key, which is in string form, and the second thing is val, which is the integer. Okay, and this is the value of this particular key. Okay, and the second operation is sum. So in this we have to return the sum of the this string prefix. Okay, so let's see what we actually have to do in this question. So let me take this code and let's understand what is the solution of this. Okay, so what we have to do. So in this we have been given these input. So we have to perform the two operation, that is insert. The second operation is sum. Okay, and in insert there are two things. First thing is key, and the second thing is value of that particular string. And in this, the only prefix is given. Okay, and this is of string type. So this value is to the insert, because in this the two things are giving, that is the key and that is the value. Like all these operations are handled in the backend side. Okay, so you don't need to worry about this. You just have to complete these two functions. Okay, you just have to complete these two functions. So let's see this. How can we do this? So for this, let me create the data structure first. So this is our data structure. Let's see what is actually the insert and what is actually the sum operation. Okay, so first what we have to do, first we are performing the insert operation, because in this is our key, this is our value. Okay, so what I will do, I will directly add this string into the data structure. So I'm going to store this, and I'm going to store the corresponding value of that particular string. Okay, so I have stored the apple and its corresponding value. Okay, now what we have to do, now we have to do the sum of this prefix. Okay, so this is the prefix and we have to return the sum of it. You can see, like, we have to return one integer, that is actually the sum of it. Okay, so let me search this prefix in our data structure. So when we'll see it, there is one prefix, that is ap. Okay, and what is its value? Value is 3. Okay, so what we have to do, we have to return 3 in this case, because this prefix is present in one of the string and its value is actually the 3. Okay, so we have to return it. So let me do this. We have to return 3. Now we have to store the second value. We have to insert the second thing, that is its value and its key and value. Okay, so what I'm going to do, I'm going to simply insert it in the data structure and I'm going to store its corresponding value. Okay, so again I'm going to insert the apple. Now this is the new case, that is, if this if the particular key is already present in our data structure, then what we have to do, we have to simply override that value. Okay, so we don't have to do like this, like you simply insert this apple once again and you are going to store its corresponding value. You don't have to do this, because apple is already present in our data structure. So what you have to do, simply you have to override that value. So like now you can see it, the 3 is stored in case of apple. So now what you have to do, you have to store 2 instead of 3. So we have to override that particular value. Okay, so now our apple will become with a value with 2. Okay, now we have to return the sum. This is our prefix string and we have to do the sum of this particular string. Okay, so let's search it where the ap is present. So when we analyze it, it is present in these two strings. This is first string and this is second string. Okay, so what we have to do, we have to do the sum of these two values. Okay, so what will be the sum? Sum is actually 2 plus 2, that is 4. So we have to return 4 over here. Okay, so this is what we have to do. So if you see it here, then you will see it 3 and 4. So this is what actually we have to do. Okay, so let's see for another test case. So let me take the test case. So now let's discuss for this case. So again, what I'm going to do, this is our data structure. So this is our data structure, and first operation is insert operation. Okay, so in this is our key and this is our value. So I'm going to store the key as well as value in our data structure. Okay, so our key is cards and its corresponding value is 2. Okay, now let's see for this case. So caught, so but caught is not present, so again I'm going to store this in our data structure, and I'm also going to store the corresponding value. Okay, again let's store the cards. So if you see, cards is already present. Okay, so cards is already present in our data structure. So what I will do, what I'm going to do, I'm going to just override that particular value of cards. Okay, so as we have already discussed, if that value is present, then what we have to do, we have to simply override that value. So I'm going to override with 3. Okay, now let's see for car. Okay, so if we will see it over here, so we have been given car in this side, in this prefix. Okay, so this is our prefix. So this is our car and we have to return 3 in that case. Okay, so let me return the sum, that is 3 over here. Okay, so we have written the car with value 3. Now let me do for some more cases, that is tried. So I'm going to store this in our data structure, that is tried, and I'm going to store the corresponding value of this. Okay, so let me just do one small change. Let me take the card instead of cards. Okay, now again the second operation is card. So there is cards is already present but card is not present. Okay, so what I'm going to do, I'm going to store the card over here and I'm going to store the 1. Okay, so now let's see for chords. So chords is not present, so again I'm going to store the chords over here and its corresponding value. Okay, now what we have to do, we have to simply, let me just rectify this thing. So instead of card, CAR. Okay, now I have to find the sum of this particular prefix. So let's search for this prefix. So it is present over here, it is present over here, it is present over here, and it is also present over here. Okay, so in this case we have to do the sum of all these, that is 3 plus 2 plus 1 plus 3, that is 3 plus 2 plus 1 plus 3. 3 2 just 6 and 9. Okay, so we have to return 9 in this particular prefix. Okay, so now you can easily understand how can we do all these stuff. Okay, so if this value, if any value is already present in our data structure, so in that case what we have to do, we simply have to override it. That's what we have to do, we have to insert it. And if we have to find the sum, so simply we have to search the prefix in our data structure, and again I'm going to sum this. So for solving these type of problem, you can do by using two methods. That the first method is using hash map. Okay, so and the second method is using tries. Okay, so you can do with any of the method. Okay, so you can also use the hash map, or if you are doing code in C++, so you can use unordered list. Okay, so you can use unordered list if you are using the C++ language, and if you are using the hash map, so you can use unordered, you can use hash map. If you are using Java, you can use hash map, and for C++ you can use unordered list. So you can also use these methods. So if you are using, suppose you are using hash map, so how can we do this? You simply add this in the hash map or unordered list, and for insertion it is pretty much easy, because when you just insert it, and if that particular value is already present in our data structure, then what it happens, it just override that particular value. Okay, so for insertion there is no problem, but when you just find the sum, then what you have to do, simply you have to search that prefix, and you can do the sum of that particular of that these particular strings. Okay, and you can return it. But what I'm going to do is I'm going to use this method, that is tries. So I'm going to use the tries method, and by using this method I'm going to solve this type of question. Okay, so let me do this. So let me take one case, that is apple. Suppose I'm going to store apple and its value is 3. Okay, so this is our root, and I'm going to store apple over here. A P P L E, and what is the value of this corresponding apple? That is 3. Okay, so you can store the apple to 3. Suppose let me take the second, that is app, and its value is 2. Okay, so again you have to store app. So A is already present, P is already present, P is already present. Now its value is 2. So you have to set this value and you have to mark this. Okay, now suppose you have to find the prefix sum of app. Okay, so let's do this. Let's find this. So this is our prefix. Okay, so what you have to do, you have to like simply over, you have to do the sum of all these. So 2 plus 3, and you can easily return the 5 over here. Suppose before this we have to insert the apps, and its value is also 2. Suppose, okay, so s is going to come over here. S is going to come over here, and its value is 2, and I'm going to mark this. Okay, now we have to find the prefix sum of this. So what I'm going to do is, first I'm going to search this prefix. So we already find this prefix, and now I have to search in this direction, in this direction, in this direction, and if suppose there are some more branches like this, so in each direction we have to find the sum. We have to traverse in each direction. So this is not a good case, because you have to traverse in each direction. Okay, so this is not a good method. So you have to resolve this method. You have to do something to like to save that this much of traversing. So you have to traverse in this case. Okay, but this is not a good method. So how can you do this? So instead of doing this, let me change the little bit, let me change some method. That is, suppose I have to store the apple. So again, what I'm going to do, I'm going to store with each character. See, suppose this is our the first string is app. Okay, so what I'm going to do is I'm going to store the value of each character, because in case of app, the prefix can be a, the prefix can be ap, and the prefix also can be app, and the each value is of 2. Okay, suppose the prefix is a, so what we have to return, we have to return 2. Suppose the prefix is ap, then again we have to return 2, and in this case also we have to return 2. So what I'm going to do is I'm going to store the value of each character. Okay, so one by one I'm going to store the value of each character. So let's see how can we do this. Suppose I'm going to store the app first. Okay, so this is our root, and again I'm going to store a first, and I'm going to store the corresponding value of that particular string. Okay, let me just shift this somewhat. Okay, so I have done like this. Again I have to store p also. Again I'm going to store p and its corresponding value. Again I'm going to store p and its corresponding value. Okay, so this is how we are going to store this. And next one is I'm going to store apple. So how can we do this? We have to store a, but we have already stored the value of a. So what I'm going to do, I simply have to store 3 plus 3 also. Okay, again for p is already stored, so I'm going to do the plus. So I'm going to maintain the value in each case. Okay, for each character I am going to maintain the value. Okay, so I'm going to store plus 3 over here, and we L is not present, so simply I'm going to insert L, and its value is 3. Okay, and the next thing is E, and its value is 3. And suppose your prefix, you have to find the sum of AP prefix. Then what you have to do, you simply have to traverse this. Okay, so this is our AP, and we simply return this sum. We don't need to traverse it and calculate the sum. We can simply return the sum of these. Okay, So you simply can return 5 over here. Okay, so this is how we can save our time. So this is more efficient method. Okay, so let's do further. So the next one is APPS, and again I'm going to store this. So A is already present, so I'm going to plus 2, again plus 2, APP, again the P is present, 2 I'm going to plus 2, and S is not present, so I'm going to insert the S separately. Okay, so like this I'm going to uh, insert these values, and again if we have to find the prefix sum, then we can easily do the sum. That is, I'm going to search this and I'm going to return this sum of the last character sum. Okay, that is 2 plus 2 plus 3, that is 7. You can easily see that how easy is to calculate the sum. Okay, and we have also saved our time, but there is one problem in this case. There is one problem, that is, if again suppose we have to insert apple, again if we have to store apple, to change the color and apple, now the value of apple is 5. Suppose now the value is 5. Now how can you do this? How can you solve this? So if you are thinking like this, like you simply add this over here. So A is present, B is present, again P is present, L is present, and E is present. You simply, if you are thinking like this, then you are wrong. Because if this string is already present, if that key is already present, then what we have to do? We have to override this value. Okay, so what we have to do? Instead of 3, we have to store the 5. Instead of 3, we have to remove this 3 and we have to store that 5 over the over this value, over this character. Okay, so this is how we have to do. But what we are doing, we are simply adding this, but we are not removing it, because we don't know that what is the value of apple. Okay, so for this what we have to do, simply I will take one unordered list, or you can, if you are doing in Java, so you can take the hash map. Okay, so for this I'm going to take one data structure, that is hash map or unordered list. So according to your preferred language, you can use these data structure. Okay, so this is our list, and I'm going to store this by using the key and pair. Okay, so first I have stored, suppose I am here, so I have already stored these values. So apple is present with 3, and app is present with value 2, and apps is also present with value 2, and now I'm going to store apple. So first what I'm going to do, I'm going to check it in this list, if on unordered list, or you can use the hash map. Okay, so first I'm going to check this key in this list, if it is present. If this key contains if this key is present in this list, then what I'm going to do, I'm going to retrieve this and I'm going to subtract with this. So see, I'm going to take 5 minus 3, that is 2. So what I'm going to do, instead of adding 5, I'm going to add only 2, because we are subtracting minus 3 and I'm going to add this. So I have just calculated one formula, so I'm simply adding with 2. Okay, so this will override it. Okay, so in each case, I'm going to do, I'm going to add 2 only. I'm going to add 2 only, instead of doing all these stuff. Okay, so what this mean? What does this mean? So this means that we are removing 3 and I'm adding 5. Okay, so suppose if we are removing 3, then we have to do minus 3 and we have to add 5. It, if we solve this operation, that it is simply going to add 2 only. So I'm going to do this and I'm going to change the value also. So I'm going to change the value with value 5. Now our apple value will become 5. This is how we are going to code this. So let's go and code this. So I'm going to code this in Java. So let me do the full screen first. Okay, now what we have to do first, we have to construct one try. Okay, so for constructing the try, we already know, like we have to construct one class, that public static node, and let's take class. Okay, so we have to create class, and we have to take one node array. Okay, that is the child. Okay, so we have to take one node array of size 26, that is the size of alphabets. And we also have to take one more variable, that is score. Let's give the name score. What is the score? Score is actually this value, like the value of each item in which we have to insert. Okay, so we have done this also. And now for the next thing which we have to construct is this hash map, in which we have to change our this value. Okay, so let's create the hash map of type string and integer. Okay, so let me give this name keyval new hash map, in which we are going to store the key as well as values, or you can say scores. Okay, so in hash map we are going to store the values, and we can also take one root element, that is node root new node. Okay, so I'm going to take the node element also. So first, now I'm going to first initialize this. I'm going to complete this function, that is the insert function. So what we have to do in insert, we have to insert the value first. We have to start the current from there, and we have to add this value if it is not present in hash map. Okay, so let's do this. So before doing this, first let me check this. Okay, so let me update this value, in which we have to subtract with this. If that value is present, then we have to subtract that number with that presented value. Okay, else what we have to do, else we can also do like this. See, if the value is not present, that means we can subtract with 0. Okay, so this is actually the same thing. If the value is not present, then we can subtract with 0, and if it present in the hash map, then we have to subtract with that particular number. Okay, so let's do the same thing. So first I'm doing this part. So I am taking one variable, that is delta. And what is delta? Delta actually this value which we are finally adding in this. Okay, so it is, let me do this, show in desktop. And what is delta? Delta is actually the value minus in which by which number we are subtracting. We are subtracting with the contained value. Like if the apple is already present, then we are just subtracting with that presented value. Okay, or else what we are doing, we are subtracting with 0. So let me use this function, that is keyval is our hash map, and we have one method, that is get or default. Okay, what this method says, if the value is present, if that particular key is present, then it will return that particular value of that key. Okay, or else what we have to do, we have to return 0. Okay, so now from there, from this line, we have updated our delta. Okay, so we have got this value, this 2. Okay, so we have got this value, this 2. Okay, and finally we are going to add this. Okay, and again what I'm going to do, I'm going to update the values in our hash map. So put, we have to update these values, key comma val. Okay, so I'm going to update the values also in our hash map. Now I've done this. Now what I'm going to do, first I'm going to take one node type current pointer, and it is going to point the root. Okay, because we have to start from root only. Okay, because we are inserting, and if it contains, if that particular node is not null, that means that alphabet is already contained. Okay, so let me write the code, and after that you are going to, you can able to understand this. Okay, so what I'm going to do, I'm going to iterate in that particular string with the characters. Okay, so from I equal to 0 and I is less than key dot length and I plus. Okay, so I'm going to iterate with, that particular string, and I'm going to store in the ch variable, that is str.char. This is not str, this is actually the key. Okay, so we are iterating in this, and this is I. Okay, so what we are doing, we are just storing each character in ch variable, and then I'm going to check that particular value in that array. See, you have already seen this thing when we are discussing that implementation of try, because in each node what it is storing, it is storing the 26 size array. Okay, and if it is a, then in this we are again storing one 26 size array. That means it is not null, and these all are null. These all are null values. Okay, so if it is not null, that means the a is present at that particular stage. Okay, so this is 0 1 2 3 4. Okay, suppose it is stored in 3, that means a b c d is present. Okay, so this is how we are going to see. Okay, so for this, what I'm going to do is I'm going to check it. If ch dot childs, not ch current dot child of childs, I'm pointing to this variable. Okay, if current of childs, like I'm accessing this array. Okay, and which index, so we have to convert that particular element in the form of index, that is I will subtract with minus a. Okay, so we can find that particular thing and is equal to null. Okay, so if that particular value is equal to null, then what I'm going to do, then I have to store the value. Okay, then what we have to do, we have to store the that particular array. So where this number got next, this is our actually the page. Okay, so what I'm going to do, I'm going to store the node in this particular thing, and if it is present, then we have to update the scores. Okay, so what I'm going to do, I'm going to current dot childs ch minus a, and we have to create one node in that particular element. Okay, so we have to uh, create one node in that particular element. So it is going to create this array, 26 size of array, if this is null. And if it not null, that means a is already present. Okay, that means a is already present. So next, what I'm going to do, then we also have to update the scores also. Okay, so for scores, what we have to do, current dot scores, then what we have to do, we have to plus that score with delta. Okay, so what we are doing, we are just incrementing that particular scores with a delta which we have calculated. Okay, and before doing this, we have to do one more thing, that is we have to update our current. Now the current is going to point the childs ch of a. Okay, now the current is going to point this node. Okay, so now our insert is completed. Now let's move toward the sum. So sum is actually pretty much easy. What we have to do, if it is null, that means we don't have the value. Suppose the prefix is xyz. Suppose the prefix is xyz, but there is no x. Okay, so in place of x, it is null. That means what we have to do, we have to return 0 over here. Okay, if the node is not present, if that number is, if that prefix is not present, then we have to return the 0. Okay, if it is present, then what we have to do, we have to return the return the sum of it. Okay, so first what I'm going to do, I'm going to start from the beginning, from the root. Okay, so I'm going to take one current, and it is going to point the root element. Okay, so again I'm starting with root, and then I'm going to just iterate the characters of that prefix. Okay, and I equal to 0 and I is less than prefix dot length and I plus plus. Okay, and again I'm going to store that character, prefix dot caret of I. Okay, so again and again I'm storing that character into ch variable, and then I'm going to check it. If current dot childs of ch minus a is equal to null, that means we have to return 0, that is not present. Else what we have to do? Then we simply have to sum it. Current is first current dot childs, first I'm going to point that to that particular child. Okay, that means ch minus a. So now it is going to point that particular element, and then finally I'm going to return the current dot score of that particular element. Okay, so now we have completed our code. So now let's run this and check for test cases, and it is giving some errors. So let me check it. So the error is in 30th line. So I think there is one extra s over here. Okay, so let me remove this, and now let's run this. Okay, so it is running absolutely fine. So let me submit this and check for all the test cases. So all the test cases are running fine. So thank you guys for watching this video, and we will meet you in the next video.